On this edition of Newsable, how will the Texas Clean Energy Project work? So how do we get from a chunk of solid coal to an electric generating gas? Let's take a step back. First, coal from the Permian Basin in Wyoming will be brought to the plant via rail and unloaded. After the coal is brought into the plant, it will be dried and ground before being transferred to the coal gasifiers. The gasifiers are essentially big metal vessels that place the coal under high pressure and heat, typically to a temperature of about 3,000 degrees Fahrenheit. Oxygen extracted from an on-site air separation unit is also added to the gasifier. All of this put together allows the coal to be chemically broken apart, leading to the creation of syngas, an industry term for the hydrogen, H2, and carbon monoxide, CO, mixture that results. The mineral and non-organic components of the coal will not be able to be turned to gas and instead will simply melt down to form what is called slag. The slag will be cooled and then collected for possible sale to be used in cement making, road building, and for roofing materials. Next, the newly created syngas will be transferred to a water-gassed shift unit. In this unit, the carbon monoxide from the syngas will be reacted with steam in order to convert it to carbon dioxide. What results will be a new syngas, rich in carbon dioxide, or CO2, and hydrogen. The syngas will then be moved to the mercury, Hg, removal unit. Here, 95% of the mercury in the syngas will be removed and converted to the more stable mercuric sulfide so that it can be more easily disposed of. From here, more chemicals are essentially cleaned out of the syngas, including hydrogen sulfide, or H2S, the compound responsible for that rotten egg smell often associated with sewage. Another compound that is cleaned from the syngas at this point is carbon dioxide. After the carbon dioxide is separated, it will be dried, compressed, and sent to two different locations. The majority of the CO2 will be transported via pipeline to oil fields in West Texas that will use the carbon dioxide for enhanced oil recovery, and the rest will be used to make urea on site, which is used to make fertilizer. After both the hydrogen sulfide and carbon dioxide are removed from the syngas, what remains is a hydrogen-rich gas that is then transported to the ammonia, or NH3, synthesis unit to be even further divided. At this point, a portion of the hydrogen-rich syngas is compressed, cooled, and sent through a catalytic reactor to produce liquid ammonia. Along with a portion of the captured carbon dioxide, this ammonia will be used to produce urea at the plant. Now, the rest of the syngas is finally ready to be used to make energy. The syngas is fed into a gas turbine, where it is used to drive a generator to make electricity. This is called primary power generation. But what makes integrated gasification combined cycle systems, like the Texas Clean Energy Project, even more innovative is what comes next. Waste heat from the gas turbine is captured and is used to produce steam, which is then used to power a steam turbine generator. The use of these two different generators is the combined cycle part of integrated gasification and combined cycle. And that is how the Texas Clean Energy Project will work.